Hey, I am Miss Wallace, and this is
Miss Sitton.
And we are from Sally Humble. We both teach 5th grade math, and today we are going to talk about adding and subtracting fractions. Okay, so we are going to add fractions with unlike units using different strategies to find equivalent fractions, and we are also going to add fractions with sums that go between 1 and 2. Okay, so when I look at this addition problem, what is something that I noticed, Miss Sitton?
Their denominators are not the same.
They are not the same. This is like saying that I have 1 apple and I have 1 orange. How many apples do I have? You can't say that because you can't add those together because 1 is apples and 1 is oranges. They have to be the same. So, can I add 1/2 plus 1/4?
Not in this form.
Not in this form. So let's look at some different strategies on how I can get an equivalent fraction. So I could draw a picture, and I'm going to show you how to do that. I can multiply the denominators to just get a quick equivalent fraction, or I could list out the lowest common multiple, meaning I'm going to list out the multiples of those denominators. So for example, if I had to find a common denominator for 4 and 6, I have a 4, and I've listed them out, and I have a 6, and I've listed them out, and I look, I have 2 that are the same. I have 12s, and I have 24, and I need to pick the lowest. So I would pick 12 as that number to be my equivalent fraction. Okay, so when I look at this, the first thing I want to do is I'm going to draw a picture. So I'm going to draw a picture for 1/2 and then 1/4. So for 1/2, okay, how am I going to partition this into how many parts?
2 parts.
2 parts, and how many shaded?
One
part shaded, right.
Part.
Okay. And when I'm drawing these pictures, I usually do my first fraction as I draw that line vertically, and then I will draw my second fraction, and I will draw those horizontally. So for this one, this needs to be partitioned into how many? 4 parts. Okay, so into 4 parts, and only 1 part shaded to represent 1/4. So I'm going to use a different color. So since I'm adding these together, I'm going to combine them because that's what adding is. So I broke this one up into 2 parts, so I'm going to break this one up into 2 parts. I broke this one up into 4 parts, so I'm going to break this one into also 4 parts. So now I can rewrite my addition problem with equivalent fractions. So how many shaded parts do I have?
4.
I have 4 shaded parts. How many total parts?
8.
8. Okay, how many shaded?
2.
How many total?
8.
Now can I add these fractions?
Now you can add them because they are both in 8s.
Absolutely. So 4 8s plus 2 8s would give me
6 8s.
Would give me 6 8s. And in 5th grade, we know that we always have to simplify our fractions. So if I'm looking at this, I can simplify 6 8s by dividing top and bottom by
2.
By 2. And if I do that, ooh, that's awful. By 2, then my final fraction would be
3/4.
3/4. Absolutely. I'm going to clear the ink. There we go. All right, so let's try another one. This time not doing the picture. We did an example that way. Now we're just going to do it by just multiplying our denominators. They're not the same, so I cannot add them. So if I just multiply my denominators, I would get 5 times 3, which would give me 15. So I'm going to rewrite my fraction. So I'm going to put my denominators as 15. Now, when I'm doing this, whatever you do to the bottom of the fraction, you also have to do it at the top. That's something we say over and over and over again in my class. So how'd I go from 5 to 15?
Times 3.
And so I do that at the top. 2 times 3 is?
6.
How'd I go from 3 to 15?
Times 5.
Also do that at the top. 2 times 5 is?
10.
Absolutely. So 6/15 plus 10/15 would give me
16/15.
Okay, now, when I'm looking at this, can I leave it like this?
No, because that is an improper fraction. Your numerator is bigger than your denominator.
Yes, and I cannot leave it that way. So, how many 15/15ths can I take out of this fraction?
1 15/15.
Good. I can take out one whole 15/15ths, and how many would be left over?
1 15.
One would be left over. So my final answer would be 1 and 1/15. Okay? All right. So now looking at this one, we have 1/2 plus 3/4. Going to go back and show you that model just one more time. Show 1/2 vertically and 3/4 horizontally. So I have my 1/2.
2 parts and shade 1.
And remember, this was vertical. The second one I'm going to show horizontal. So over here, I'm doing
4 parts and shading 3 of them.
1, 2, and 3. All right. So I'm looking at this, and now I need to combine them together. So I broke this one up into 2 parts. So this one also gets broke up into 2 parts. This one in 4 parts. So also this one into 4 parts.
Now we have a common denominator.
Now we have a common denominator because both pictures have how many parts?
8.
Good. They have 8. Okay. How many shaded?
4.
How many shaded?
6.
Okay. And 4 8s plus 6 8s would give me
10 8.
10 8s. And once again, that numerator is larger than the denominator, so I can't leave it that way. How many 8 8s can I pull out of this fraction?
1.
I can pull out 1 8 8s, and how many would be left over?
2.
2 would be left over. Okay, could I leave it like this?
You can simplify it.
I can
2
also
8s
simplify
has a
it.
common factor.
Good.
2 and 8.
Good. 2 and 8 also have a common factor, which would simplify that to be 1 and 1/4. Absolutely. Okay. Oh. All right, so that's adding, and now we're going to move on to subtracting, which is basically the same strategies, but instead of adding, now we're subtracting. Okay? All right, so looking here, I'm going to create those fraction models again. Okay, so looking here, I have thirds and I have fourths. Remember, we do it vertically and then horizontally. So here I have 1/3, so I'm going to vertically put this into 3 parts, and I'm going to shade in 1. This one going to be broken up into 4. And how many shaded?
1.
And 1 shaded. Okay, so if I'm looking at this, remember, I have to find a common denominator. So if I broke this up into 3 parts, I also break this one up into 3 parts. This was fourths, so this one will also be fourths. Okay, so now let's rewrite them. How many shaded?
4.
How many total?
12.
How many shaded?
3.
And how many total?
12.
Okay, so 4/12 minus 3/12 gives me
1/12.
And in your picture, if you wanted to, you could also come back to this picture and say, 3, I'm taking away 3 of the 12. If you wanted, you could come over here and X out 3 of them and see that I have 1 out of 12 left over. Oops. Oh, okay. Clear ink. Awesome. All right, so that was using those fractional models. Now I'm going to tell you 2 other ways that we can do this with subtracting fractions. So now, what is different about this subtraction problem?
We have a mixed number.
We do. We have a mixed number. We didn't really see an example with that before, so let's see what we can do. Here, I want to change the mixed number to an improper fraction. So if I'm looking here, I'm going to say 3 times 1 gives me
3
plus 1 more.
is 4/3.
Okay, so I'm going to change 1 and 1/3 to 4/3 minus 1/2. Well, once again, my denominators are not the same. So I could draw my model. I could multiply them, or I could list out those multiples. So let's do that because we haven't done an example for that one yet. So let's do our 3.
3, 6, 9, 12.
Okay, we'll stop there and let's do our 2.
2, 4, 6, 8.
Okay, and do we have numbers that we see that are the same?
Yes, we do.
We have our 6. Absolutely. So I see by listing out those multiples that they share a 6. So I'm going to use 6 as that common denominator. Okay. Okay, how did I go from 3 to 6?
Times 2.
And whatever I do at the bottom.
Uh-oh.
How do I go back? Oh, it was down here. Haha, there it is. Okay, whatever I do at the bottom, I do at the top. Okay, so 2 times 4 gives me
8.
Good. How'd I go from 2 to 6?
Times 3.
And we'll do that at the top. 1 times 3 gives me
3.
All right, and 8 6 minus 3 6 gives me
5 6.
Okay, so now we're going to do the same problem, just a different method. We're going to do it vertically. So coming over here, yeah, we have 1 1/3 minus 1/2. Okay, well, based off this problem, we already know what our common denominator is, so let's go ahead and change those up. We know that we're going to get 8 6 and 3 6. So over here, I'm just going to change this over here to a whole, well, I know my common denominator is 6. So over here, I'm going to have a whole 1. And instead of a 3, I know it's going to be a 6. And then over here, instead of 1/2, I know that denominator is going to be a 6. How'd I go from 3 to 6?
Times 2.
So I also do that at the top. And 1 times 2 gives me
2.
2 to 6. I did.
Times 3.
And also do that at the top. All right. So if I do this vertically, I'm looking at this, and I have 2 6 minus 3 6. Can I do that?
You cannot. You're going to have to borrow or regroup and take from that whole.
Absolutely.
Think of it as 6 6.
Good. So if I'm taking away a whole number, if my denominator here is 6, what would be the same as 1 whole? And she said it would be 6 6. So I'm going to bring that over here, plus 6 6, because I regrouped it, so I have to add it over here. What is 2 6 plus 6 6?
8 6.
Good. So now I have 8 6 minus 3 6. Now can I subtract that?
Yes.
And I get 5
6.
6 once again. Just another strategy to get the same answer. Okay. There we go. All right, so just to kind of wrap this up, we're going to kind of apply what we've learned with adding and subtracting fractions. And I have Aaron mixed 2 3/4 cups of almonds and 1 7/8 cups of peanuts. And how much more almonds than peanuts does Aaron have? So if I'm looking here at my question, I need to do what with these two numbers?
Subtract, because of that how much more. You're
Good.
finding the difference between Aaron's almonds and her peanuts.
Good, because we're going to find a difference. So I'm going to subtract. So I'm looking here and I have 2 3/4 minus 1 7/8. Once again, multiple strategies. You can turn these into improper fractions, or you can do it vertically. Let's change it to improper fractions, because I feel like that's a skill that's super important that needs to be remembered and repeated over.
Practiced.
Yeah. So 4 times 2 is
8
plus 3.
11/4.
Good. I have 11/4 minus an 8 times 1
8
plus 7.
15/8.
Okay. Once again, I do not have a common denominator. Now, I could multiply these two and I could get 32, but I'm going to have to do a lot of simplifying because that's a larger number. But if I look at this and I know my multiples, I quickly see, well, I know a 4 can be an 8 because it goes 4, 8. Well, that would mean I don't have to do anything to this fraction because it's already an 8. So I'm just going to change this 11/4, okay? So I'm going to make that into a 8. Okay.
Times 2.
Good. I did times 2, and so do that at the top. And 11 times 2 gives me
22.
22. And I can just leave this the same, okay? So if I'm looking at this, I can do 22 eighths minus 15 eighths, and I get
7 eighths.
Good. 7 eighths. So how much more almonds than peanuts? She has 7 eighths more almonds. Okay? There we go. All right, so some things to remember when adding and subtracting fractions. You have to have a common denominator. There are multiple strategies for you to be able to find those common denominators between fractional models, between just multiplying those denominators, or just listing out those multiples and finding the one that they share that is the lowest.
Sounds good.
Awesome. Thanks,
Okay.
guys.
Thank you.